Okay, lesson 5 is a little bit of a tough one today. And so we're gonna do a little bit of manipulating an equation. We're gonna be dividing by 2 and squaring. All right, it sounds like it's maybe not that hard to divide by 2 and then square a number, but we're gonna do our best to do that. That's kind of the punchline. I just spoiled the whole day. So let's go ahead and chat about solving quadratic equations, but today by completing the square, And so that is one of the methods that we're going to use to solve quadratic equations. We've already solved by graphing, we've solved by taking square roots, we've solved by factoring, using the zero product property, and now we're going to talk about completing the square. So a perfect square, again, is when you have a binomial multiplied by itself. And so we practice a little bit about multiplying an expression, by itself, and doing that double distribution. You would have called this FOIL back in middle school or Algebra 1. And so when we, 16 hit it, come on. And so what we have here is a quadratic that is a perfect square. And so part of it is that when we square this, we need to make sure that we don't just square the x and square the 4. That's part of it, but there's also this part where we take x times 4 and 4 times x, right? And so we basically double this product and we get 8. Here we have 2x minus 5 squared. That's going to give us 2x minus 5 and 2x minus 5. When we do that multiplication, we get 2x times 2x. We get 2x times negative 5. We get negative 5 times 2x, and then we get negative 5, and negative 5 makes a positive 25. And so here we end up with 4x squared minus 20x's plus 25. And so what I want for us to be able to do is, first of all, understand how the multiplication works so that when it comes to the factoring, we can handle that. All right? Here, if I'm going to do guess and check, I would say, all right, well, x times x is going to give me x squared. And a 4 is going to be a 2 and a 2, but we need those signs to be negative, all right? Negative 2 and negative 2. So this gives us x squared minus 2x and another 2x, is minus 4x's, and then a positive 4. So this is x minus 2 squared. It's just another way to write that. Over here, we've got 9x squared plus 30x plus 25. We know that 9x's is going to be 3x's and 3x's. We know that the 25 is going to be 5 and 5, and it looks like these are both going to be positive. And so what we have here is 9x squared, 15x's and 15x's add up to 30x's, and then 25. And so what we have is 3x plus 5 quantity squared. So the reason why I'm showing you this is because we want to understand both the multiplication side and the undoing it, or the reversing it, the factoring side. How to get from a squared binomial to the trinomial that is a perfect square, or to take a trinomial that is a perfect square and factor it as the same linear factor times itself, all right? This x minus 2 squared, 3x plus 5 squared, 2x minus 5 squared, x plus 4 squared. And if we understand this process of factoring, understand this process of multiplication, then we should be able to handle what we're going to do today and explore today, which is called completing the square, And so why they call it completing the square is we are going to have to find what terms or addends we will need in order to make a perfect square. And so what I want us to do is I want us to just kind of think real quick and briefly but thoroughly about making a perfect square out of x squared and 6x's. How many ones do we need to make a perfect square? How many unit tiles must we add to complete the square? Hopefully you can tell that if we are going to have unit tiles in here, 1 by 1 units, that we would need 9 of them. We would need 1, 1, 1, 1, 1, 1, 1, 1, 1. This would add up and create a total of 9 unit tiles. Write the expression to represent the sum of the areas of the tiles. This is going to be our x squared, our 6x's, and our 9 ones, right? A 3 by 3 there makes 9. And write the expression of the length times the width of the completed square. Well, this will be x plus 3 times x plus 3. When we multiply x and 3 by x and 3, then we are going to get x squared plus 6x plus 9. So what I want for us to think about, this is kind of a big question here. How do the 6x tiles in the model relate to the lengths of the completed square and to the number of tiles used? All right, so I want for you to be thinking about how can I get from x squared and 6x's to know that this number is going to be 9. Know that this number is going to be 9. That's the kind of the big picture question that I want for you to ask yourself over the next few minutes so that we can predict how many tiles we need and what the expression is that represents this situation. All right, so I will do this one right here, which here I've got an x squared, I've got an x, I've got an x, and I've got 1. So this is x squared plus 2x's and 1. That's the expression here. But in factored form, this whole thing is x and 1. This whole thing is x and 1. So we understand that this is x and 1 times x plus 1. This expression, x squared plus 2x plus 1, can be written in factored form as x plus 1. Now you might kind of ask yourself this question of like, okay, what are we doing and why are we doing it, et cetera, et cetera. For example, here, we're going to have 1, 1, 1, and 1. We're going to have all of these little bitty tiles in here to note that this is x squared and how many x's? Well, I've got 4 x's and I've got 4. We've already shown that this is the same as x plus 2 times x plus 2, right? X and 2, squaring it, length and width, base and height, etc., and that gives us this perfect square. I want for you to fill in this one. And I want you to think, maybe without even looking at the picture, how many little tiles you are going to have, all right? Notice how this 4 is a perfect square, it's 2 and 2. How this 1 is a perfect square, it's 1 by 1. And so think about what is going to go into that spot there, and I'll fill that one in for you. So let's think about completing the square. Let's think about what we do to make sure that we can complete this square. Well, really what's happening here is we are cutting this number in half, and then we are going to square that number. So what I have here is, I know if we backtrack a little bit, we can think about this. We've got 2, half of 4 is 2, because we have 2 times 2, and then that gives us 4 tiles here. 2 plus 2 makes 4. Over here, 1 plus 1 makes 2, so we had 2 x's, half of that is 1, 1 squared is 1. Going back still a step further here, 6 cut in half is 3 and 3, that's the question we're asking here. And then 3 squared is 9. So we're cutting that number in half. Cutting this number in half, what's the grand total here? And then how many tiles are there going to be? You can kind of predict that. You don't need to draw that one out. That probably would take forever. So cutting that number in half and then squaring it is going to give me 49. Half of this number squared is going to be 25. Half of this number squared, negative 4 squared, is still a positive 16. So we can predict what this is going to be by taking this number divided by 2 and squaring it. And that's what we are going to use to complete the square. I can take negative 8 and divide it by 2 and get negative 4, and when I square it, I still get 16. So over here with these odd numbers, I want to come back to these in a little bit because these odd numbers don't divide by 2 very well. It gives us a decimal. And then squaring a decimal is awkward. So when we divide by 2, we're going to leave it as a fraction, and then we're going to square it. I'm going to come back to those. Remind me to do that. Remind me to do that. Hopefully I get the reminder. All right, I want you to just yell at the screen, Mr. Hibbett, go back to that one so we can talk about that investigation. So this is essentially our directions. Go ahead and copy those down. These are our step-by-step process to complete the square. We're going to move c to the other side of the equation. We're going to divide by a on both sides. We are going to add b divided by 2, whatever this number is, we're going to cut it in half and then square it. We're going to add that to both sides of the equation so that we have a perfect square on the left. And on the right, it doesn't matter if it's a perfect square, but when we have a perfect square on the right, we can take the square root, we can write it in its factored form, and then when we take the square of that perfect square, we get x plus or minus some number, great. On the other side, we have a square root that we have to simplify. All right, and that might be a little bit of a hassle for us, but we're going to solve by taking square roots, essentially is what we're doing. So these are the steps, And I'm going to show you, I'm going to model a little bit of what this looks like for us. The first thing I'm going to do is move the c value to the other side. All right, so I'm adding 8 to both sides. I'm leaving this space here because I want to add something to both sides. That thing that I want to add to both sides is going to be half of this number squared. Well, we already did x squared plus 2x. We know that we're adding 1. The reason why we're adding 1 is because half of this is going to make that a perfect square. All right? X plus 1 times x plus 1 is going to give us x squared plus 2x plus 1. All right? If we cut this number in half and squared it, then that number that's cut in half, that we're squaring, that we've added to both sides, is going to be this number that's being added to our x value. All right? A is 1, so I didn't have to divide by a, but that's going to give me 9. All right? Now, when I take my square root on both sides, I'm going to switch colors here just so we can see the transition to when I had this expression versus when I took the square root, I get plus or minus 3. Now, something that we saw last time and some of the later examples in our notes, and then again we saw it in our classwork, is we're going to subtract 1 from both sides. But we're going to write it as -1 plus or minus that 3. What I want for you to understand is that we are taking -1 minus 3, which is going to give us -4, and we're taking x is equal to -1 plus 3, which is going to give us positive 2. So we have both of our solutions here, both of our solutions. Now, this worked out with rational numbers because we could have solved this by factoring. X plus 4 times x minus 2 would be the factored form of this, which means that x equals -4 and x equals positive 2 are the solutions. Let's go ahead and explore this one again. We're going to add 4 on both sides. And then we're going to cut this number in half. What's half of 4? Half of 4 is 2. What is 2 squared? 2 squared is 4. So I'm going to add b over 2 squared to both sides. I'm going to add b over 2 squared to both sides. If we want to, we can write it as 4 over 2 squared, if that's the way that we want to write that. And if we type that in our calculators, we are going to know that that's going to be 4. 4 and 4 together make 8. On this side, we have x plus b over 2 squared. So half of this number is 2. So when we are completing the square, we can now take the square root on both sides. And we have the plus and minus, or positive and negative, square root of 8. Now, when it comes to the square root of 8, it would be wise for us to simplify that radical before doing any other work. Now when I subtract 2 from both sides, I have this solution. This is an irrational pair of solutions. I got -2 minus 2 square roots of 2 and -2 plus 2 square roots of 2. These are not like terms. I can't add them together. This one has a square root of 2. This one does not. So I will keep them separate. Do you know what green number we're adding to both sides? Do you know how to write this binomial with that b over 2 that we are squaring? That's the important question, so we want to make sure that you get that. Here, this is already set up in this form with the c value on the other side already. The opposite of c is already over there. And so for this one, we have to be attentive to the fact that we have an a value. So, since I've got this already, what I want to do is I want to divide everything by 2. When I divide by 2, I get this. Now this might be a little alarming to us because now we have a fraction. And whenever we've done our factoring, we have not dealt with anything that has a fractional coefficient. But this is our new b value. And we're going to take that new b value and we are going to divide it by 2, and then we are going to square it. So I'm going to add 1/2 over 2, and then square it. And I'm going to add 1/2 divided by 2, and then square it. So what is 1/2 divided by 2? 1/2 divided by 2 is 1/4. 1/2 divided by 2 is 1/4. That might require a calculator from you to either divide 1/2 by 2 or to add it to 3. Either way, your calculator may come in handy here, but this is the number that is with x and squared. B divided by 2 is this number here. All right, and that is the thing that is squared. I know that might be tough for us, but we can handle that. With my calculator, I'm going to I can either do this using math, or I can let the calculator take 3 plus 1/4 squared, or 3 and 1/16. Whoops, let me do parentheses here. 1/4 squared, and then convert that to a fraction. And this gives us 49/16. How do I do that? I use my calculator, all right, or I use my brain. You can do the elementary math there, or you can use a calculator to help you with that. When I take the square root on both sides, I get the plus or minus square root of this, which is 7/4. And now I just need to subtract 1/4 from both sides. So I'm going to write over in this space here, x is equal to negative 1/4 plus or minus 7/4. Look at that, these fractions have a common denominator. Negative 1 minus 7 is negative 8/4, which is going to be negative 2. And then negative 1 plus 7/4 is going to give us positive 6/4, which simplifies to be 3/2. So these are my two solutions for this quadratic equation. Let's go ahead and try the next one. All right, I'm still moving, I'm doing all this work here. X squared plus 6x equals negative 34. We are going to take half of this, and that's what we're going to add on both sides. I'm going to add half of 6 squared. Half of 6 squared. So that gives me x plus 3 times x plus 3, right? If I know what 6 divided by 2 is, then I know what this factored form is. I don't have to think about factoring it, and neither do you. If you divided this by 2, that gives you 3. That's the number that you're squaring, that gives you 9. All right, but we're going to write it as x plus 3 squared. If you factor this or FOIL this, it's going to give you that. Over here, this is negative 25. When we take our square root of our negative numbers, we are going to have this I component. When we subtract 3 from both sides, we get negative 3 plus or minus 5i. This worked out pretty well. There's no extra work that we need to do. All right? So what I want for you to see with this completing the square is that the work might require a little bit of you and a little bit from you as far as dividing both sides by a, moving the c value to the other side, etc., etc., etc. Here, I'm going to subtract 3 x's, and then I'm going to divide everything by 2. And then I'm going to take b, why did I divide by 2? Because a was equal to 2. Now for this part, I need to add on both sides, I'm going to rewrite this, sorry. I'm going to add on both sides half of negative 3/2 squared. Half of negative 3/2. So half of negative 3/2 is going to be negative 3/4, and that's what I'm squaring. That's what I'm going to add to both sides. And so, that thing that I squared is going to go in here, half of b. On this other side, I don't care what that number actually is, folks. I don't care that that's going to be 9/16. Instead, I'm going to use my calculator to take negative 2 plus 9/16, and I'm going to write that as the improper fraction, negative 23/16. Now when I take my square root on both sides, it's important that this is negative because this was negative here. All right? When I take my positive negative square root of 23/16, I'm going to get I times the square root of 23 over 4. To solve this, I'm going to add 3/4 to both sides, which means that x is equal to 3 plus or minus I squared of 23 over 4. All right? what I want for you to try, all right? Try to do these. You can make progress. You should all be able to get F correct. And my hope is that you can do some good work on G. I do want you to also be reminded of what these answers are here, because these got a little funky for us. And I want to be okay, I'll probably have you do F. You do this one. But really what we're going to do is take half of 15. Whoops. And that's what we're adding. Here we're going to take half of 11, square it, and that's what we're adding. So you do F. I'm going to write out what this is. Whoops, x squared. X squared plus 15x plus 7.5 or over 4, or 7.5 squared, which is 225 over 4. And this equals x plus 15 halves squared. Here, I'm adding, to complete the square, I'm adding 11 squared over 2 squared, all right, which is going to give me x plus 11 over 2 squared. So the whole punchline here is that when we complete the square, we're making a perfect square that we can then take the square root of, all right? And if we've done that, then we should be solid. I would love for you to see, or I'd love for you to show me F. What are you going to add to complete the square? And then write it in its factored form. All right, you should hopefully be able to use completing the square to solve quadratic equations.